ductility for beams. If you are having less than 0.08 of FCK, what is FCK? Miscible compressive strength of a concrete. Say for example you are using M20 grade concrete at 1.6 Newton per mm square of answer, then if that is the stress acting in a beam, you have to design as per the section 7, it is design of column. Beam shall preferably be width to depth ratio more than 0.3. Beam shall not have width less than 200 mm. The depth of the beam more than 1/4 of clear span. And width of the beam you have three conditions. There are some cases which you have wider beam and column might be much shorter. This is the case. In plan you can see this is a column reinforcement, and at all the four faces you have reinforcement in the column. Take this as C2 distance. C2 is column width. Okay. Now you have beam which is more than the width of the column. Here you can see a stirrups and reinforcement, and at both the sides you have stirrups and reinforcement in adjacent to the column. Now if in this case you have to check that this distance adjacent to the column you have some distance, so this distance not greater than smaller of C2 and 0.75 C1. So for your column you have two dimensions, the width wise and depth wise you have two dimensions. If your beam is extending more than column, then your distance should not be more than the column. So this is what mentioned here. I will say you a case. Column is 1 feet of width and your beam can extend at both the sides of how many feet? 0.75 feet and 0.75 feet. 0.75 times C1. What is C1? C1 is this and this distance. Imagine your column is having 1 feet by 1 feet. Now your beam should not go more than 0.75 feet and 0.75 feet. So totally 2.5. If you are having 1 feet column, your beam width maximum you can extend up to 2.5 feet only. How to increase ductility in dimensions? So these 3 points give you dimension clarity. Width of the supporting member C2 and 0.75 times breadth of the supporting member C1. So this distance should be totally 2.5 feet if you have 1 feet of column distance. Beam is more wider than the column. This kind of case which you have discussed right now. If you improve ductility, your building will not collapse during earthquake. Why you are increasing ductility? Your building should not fall immediately. This is called detailing. How you place the reinforcement is detailing. If you look at this picture, how many legs are here? 1, 2, 3, 4, 5, 6 legs are here. The stirrups might be like this also. See, this is also a stirrup. It is not mandatory to close the stirrups. The stirrups will be like this when your width is much higher or depth is much higher. So it will not get closed, it will be open. Open leg stirrups will be there. Going for a site engineer or design engineer, you will be knowing these things. Currently we have looked into dimensional aspect. Now reinforcement aspect. Longitudinal reinforcement, their beam shall have at least two number of 12 mm diameter each at the top and bottom face. This is top face and this bottom. At each side you should not have less than 12 mm and two numbers. And minimum longitudinal reinforcement steel ratio, rho minimum in any phase should not be 0.24 root of FCK. What is FCK? Compressive strength of concrete, yes. Divided by Fy is meant by what? Steel. Take M25 grade concrete and Fe415 grade steel. 2.89 into 10 power minus 0.0029. And bottom steel at the supports at least half of the top. Maximum at the center you will be having positive bending higher. But if you check at the corners, negative moment will be higher. Only at the center of the beam, bottom rods maximum. Why? Because bending is higher at center only, but at the end shear and negative moment is higher. You are providing 4 rod at the top, how many rods should be at bottom? 2 rods, at least 2. That is why they are mentioning at this point. Total amount of steel from calculation, whatever is there, you can use it. 2 number of bars should be in full length, should be followed for reinforcement. If relatively less steel is present in tension phase, which yield first. You can see vertical stirrups should be smaller than the dia of the main rod. When as a designer you are designing, longitudinal rod is 12 mm diameter. What does the code says? The stirrup should have lesser thickness than that. If you are providing 16 mm dia rod, stirrup should be 12 mm, so that you will be not having any compression failure. Okay, during any earthquake, which member should fail first? You have two materials. One is concrete and another one is steel. Which material should fail first? If concrete fails, all the concrete element will fall in the floor. If steel fails, what is going to get happen? If steel fails, if concrete is failing, what will happen? It makes injury, isn't it? It makes injury to the people. If steel fails, what is going to get happen? Collapse, immediately collapse is going to get happen. Okay, how you want to design? If concrete is going to collapse first or steel should collapse first? Concrete should collapse first, and it should not collapse immediately. While the steel is elongating, the concrete should be there, and while it is going to fail, the concrete should fail. Steel should not fail first, concrete should fail only at the last stage. Immediately, the concrete should not fail. During the bar is elongating, the concrete should withhold the bar, and during the failure, the steel member has to fail. This is what you imagine a chain. You imagine the chain links, and all the links of the chains are there. Only one weak link is a concrete. You make one link as a concrete and rest of the link as a steel. You stretch it. Which link will get failure soon? Concrete link will get fail soon. Rest of the members will be much safer. So this you have to remember. This is a ductile failure, hence it is desirable. So during any failure, the member should not fail immediately. Your steel should elongate and then fail. That is called redistribution occurs in a beam until eventually the concrete crushes in compression. This failure is called ductile behavior. This is required for a structure. For that, what you have to do? More steel on tension phase is not necessarily desirable. What is the tension part? Bottom or top? Bottom is tension. So at the tension side, more steel on the tension phase is not necessarily be desirable. So more steel is not required at the bottom. If you are providing only minimum number of steel, then this kind of failure occurs. Now how the ductile failure will be is, I will show you in next slide. The ductile failure is a character which may vertical crack starting from the stretch of the beam face. This is bottom face. If beam is failed by ductile mode or brittle mode, which could be found in the post damage of earthquake. After earthquake, the people structural engineer specialist will visit the structures which got failed, and during the inspection they will check that either crack came from bottom or from top. There is a reason why if a crack is projecting from downward, it is one type of failure, and if crack is projecting from up to down, you can see some cracks here. Can you see some cracks in your beam? Is it from bottom or from top? Is it? Yes. So there is a reason if crack project from top or crack project from bottom. So there is technical detail. The ductile failure is a character which may vertical crack starting from what phase? Stretch of beam phase and going towards mid depth. So if a beam fails by ductility, it fails, the crack will project from bottom and it goes to top. When during the inspection after the post earthquake, the inspection engineer will know that either this beam is designed for earthquake resistant structure or ordinary structure. By viewing you can observe. Okay, now shear failure. A beam may also fail due to shear action also. I will send you one picture which has been recently observed in the metro piers. You have metro line and the piers are there. Their piers, only the concrete is get crushed and the concrete member is ejected outside. There was one failure, and if you imagine only the concrete gets ejected and steel members are still as it is. So this kind of failure could be observed in a structure. A beam may also fail due to action of shear. So this failure is due to shear. The shear cracks will always be inclined towards 45-degree horizontal. What crack you observe here? Either it is inclined or straight. Inclined to 45 degree, you check that. Is it inclined to 45 degree? Yes. There is a crack here, I can see. This will be, if it is 20 degree or 10 degree, it is not due to shear. There are two reinforcement. One is longitudinal reinforcement and one is stirrups. If minimum number of stirrups are not provided in beam, it will provide inclined cracks. 45-degree cracks exactly it will be showing. If this kind of cracks is been observed, then it is called shear crack. The beam is having insufficient stirrups. It develops at mid depth near to the support and grows towards the top and bottom face. In order to reduce this kind of shear crack, you have to introduce closed loop stirrups are provided to avoid such shear cracks. What is closed loop? This distance you have to reduce. If you see any inclined crack, how to rehabilitate that? The stirrups should be closer. If they have provided stirrups for 1 feet, you have to reduce for 150 mm. That is half feet. If you provide like that, then you can rehabilitate that. Closer loop of stirrups has to be provided to avoid such shear action. Can you see the beam is being collapsed by what mode? Ductile or brittle? Ductile mode. Why? The cracks are developing from bottom. This is required. Then this is called shear crack. 45-degree of crack at the top. From the top, if it is created, then it is called shear crack. This is what it is indicated here. If this kind of cracks are observed, what you should do? Stirrups should be placed closely. You have to place closed stirrups in order to overcome this effect.